Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to work out some simple word problems involving fractions. And as you can imagine, fractions are going to show up on both the mathematics knowledge as well as the arithmetic reasoning subtest of the ASVAB. What's more, I want to mention that about 6 months ago, I posted a video called Learn Almost Everything About Fractions in 30 Minutes or Less. Um, if for some reason you struggle working with fractions, you may want to watch that video prior to attempting the problems in this video. I'll put a link to that video in the description of this video. But that said, none of these problems are going to be too difficult. And for that reason, I recommend that after I read each question, you pause the video, attempt to work out the question on your own, and then resume playing the video to check your solution. So all that being said, let's go ahead and get started. In total, there are going to be 10 problems in this video. All right, this first question says, Jill has 3 full pans of brownies. Each pan made 10 brownies. She gave 3/8 of the brownies to her friends. How many brownies did Jill give away? So for this one, we have to figure out first how many brownies she made in total. And we're told that she made 3 full pans, each containing 10 brownies. So that's going to be 10 times 3, which we should know is 30. Okay. What's more, according to the problem, we know she gave 3/8 of all of her brownies away. So that's going to be 30 times 3/8. That is to say, we're going to have to figure out how to multiply a whole number by a fraction. In case you haven't seen how this is done in a while, there's a trick to it. You simply rewrite 30 as a fraction by placing it over 1. Any whole number can be rewritten as a fraction by placing it over 1. I asked you to write 5 as a fraction, for example. You would just say that's 5 over 1. And again, 5 divided by 1 is 5. All right, now that we've done that, the next step is to simply just multiply straight across. That is to say, we're going to do 30 times 3 as well as 1 times 8. And let's go ahead and work that out. 30 times 3 is 90. 1 times 8 is 8, given that 1 times anything is just itself. And now we're at this point. We have 90 over 8. Well, if you haven't worked with fractions in a long time, you may have forgotten that you can regard all fractions as long division. So you can read this as 90 over 8. And in addition, you can also read it as 90 divided by 8. And that's what we're going to do to convert this improper fraction here to a mixed number. So let's work on this long division. We're going to start by asking ourselves, how many times does 8 go into 9 without going over? That's going to be 1 time, given that 8 times 1 is 8. 9 minus 8 is 1. We're going to drop down this 0. And the question becomes, how many times does 8 go into 10 without going over? That's going to be 1 time, given that 8 times 1 is 8. And this leaves us with 10 minus 8, which is 2. All right, so if you watched my video on long division, you may be prompted to place a decimal here and a couple 0 placeholders. But we have enough to write this improper fraction as a mixed number. So this 11 is going to be our whole number. Our remainder right here, 2, is going to be our numerator of our fraction here. And this 8 right here is going to be our denominator. And of course, we can reduce 2 8s pretty easily, given that both 2 and 8 are divisible by a common factor of 2. So let's go ahead and do that. This becomes 11, and 2 divided by 2 is 1. 8 divided by 2 is 4. So the answer to this one is 11 1/4 brownies. So that's that one. Again, this is pretty involved. You had to rewrite a whole number as a fraction, multiply those fractions, and then perform long division to convert an improper fraction to a mixed number. Again, an improper fraction is a fraction in which the numerator is bigger than the denominator. 90, of course, is bigger than 8. So that's that one. Let's go ahead and move on to the next one. All right, number 2 says Aaron walked 3/5 miles each day for eight days. Let me grab my pen real quick. Number 2 says Aaron walked 3/5 miles each day for 8 days. On the 9th day, she walked 1¼ miles. How many total miles did Aaron walk? So we know that for 8 days, she walked 3/5 miles, 3/5 of a mile. So that's going to be 8 times 3/5. And on the 9th day, she walked 1¼ miles. So this is the problem we're trying to work out. As you can see, we have multiplication involving a whole number and a fraction, as well as addition involving a mixed number. So let's see how we're going to deal with this one. The very first thing I'm going to do is perform this multiplication right here. Again, I'm going to write 8 as 8/1 times 3/5. And I know that I'm going to have to convert this mixed number to a fraction to add it to this fraction over here. And let's go ahead and do that. To convert a mixed number to a fraction, you do 1 times 4, which is 4, plus 1. So that's 5/4. Okay. All right. As we did in the first problem, we're just going to multiply straight across here. This becomes 8 times 3, which is 24/5, plus 5/4. Now, unlike multiplying fractions, you have to have the same denominators in order to proceed. So we're trying to find a value that both 5 and 4 go into evenly. And the most obvious denominator would be 20, given that 5 times 4 is 20 and 4 times 5 is 20. So let's go with 20 here. To get 5 to be 20, we have to multiply 5 by 4. So we're going to have to do that to its numerator as well. That is, we're going to do 5 times 4 to get 20 here, and 24 times 4 to get the numerator. And I'm going to work that off to the side so as not to make any simple mistakes. 4 times 4 is 16. We're going to carry a 1. 2 times 4 is 8, plus 1 is 9. So this becomes 96/20 plus, and let's convert this 5/4 to have a denominator of 20. We're going to multiply 4 by 5 and 5 by 5. 4 times 5 is 20. 5 times 5 is 25. All right, now that these fractions have the same denominators, we can go ahead and add their numerators. So the denominator is not going to change when you add fractions. But that said, this is going to become 96 plus 25. And I'm going to do that off to the side so as not to make any simple arithmetic mistakes here. 96 and 25. 6 plus 5 is 11. Carry a 1. 9, 10, 11, 12. So this is 121/20. And likewise, we want to take this improper fraction and convert it to a mixed number so we can answer this question. So we're going to treat this fraction here as long division, and we're going to write it as 121/20. And we start by asking ourselves, how many times does 20 go into 1? It doesn't. How many times does 20 go into 12? It doesn't. How many times does 20 go into 121 without going over? Well, 2 times 6 would be 12. Therefore, 20 times 6 would be 120. So we know this is going to be 6 here. And we're going to write 6 times 12 is 120. So we'll subtract that. 121 minus 120 is 1. Okay, so we can't proceed without adding a decimal here. So we know we're done. Again, we're going to write this as a mixed number. So this is going to be our whole number. This is going to be our numerator, and this is going to be our denominator. So, as it happens, Aaron walked a total of 6 and 120 miles during the course of those 9 days. So that's that one. All right, number 3 says a jug of drinking water contained 2 and 1/3 gallons. If 5/7 of a gallon is drunk each day, how much water was left in the jug after 2 days? So in this case, here's what we have going on. We have 2 and 1/3 gallons of drinking water. On the first day, we drank 5/7 of a gallon, so we're going to subtract 5/7 from it. And on the second day, we also drank another 5/7. So by working this out, we'll know what our answer is. Let's go ahead and convert this mixed number to an improper fraction to start. We have uh, 2 times 3, which is 6, plus 1 is 7. So this is 7 over 3 minus 5 over 7 minus 5 over 7. And as we saw previously, when we were adding fractions, we could only do so if the denominators were the same. Well, that's the case for both the addition and subtraction of fractions. In order to add and subtract fractions, the denominators have to be the same. So in other words, we want to rewrite these fractions such that they have a common denominator of both 3 and 7. And the most obvious way to do that is to rewrite these fractions with a denominator of 21, since both 3 and 7 go into 21. So that's what we're going to do here. Okay, so how would we make a denominator of 3 become a denominator of 21? We would multiply it by 7, of course. And what we do to the denominator, we're also going to have to do to the numerator. So 7 times 3 is 21. 7 times 7 is 49. How would we write a denominator of 7 as 21? Of course, we would multiply it by 3. 7 times 3 is 21. We're also going to have to do that to the numerator there. 5 times 3 is 15. And we know this one's going to be the same. So let's go ahead and just copy that down as is. And as you can see, now that we have denominators that are all the same, we can just combine this fraction like this. This becomes 21 in our denominator and 49 minus 15 minus 15. Okay? And I'm dealing with the new version of OneNote here, so just bear with me, the controls are a little bit different. 15 and 15 is 30, so this is the same as 49 minus 30 over 21. We should be able to do that in our head. That becomes 49 minus 30, which is 19 over 21. And 19, as it happens, is a prime number, which means it's only divisible by 1 in 19. So we cannot simplify or reduce this fraction any further. So the answer to this one is 19 over 21 gallons are left if you start with 2 and 1/3 gallons of water and drink 5/7 of a gallon of water each day. Okay, so that's this one. All right, number 4 says Mia has 24 yards of ribbon. She gave 10 yards to her sister. Mia now wants to work on a project that requires 1 2/4 yards of ribbon per project. What is the greatest number of projects that Mia can complete with this ribbon? So first, let's address the fact that she gave 10 yards to her sister. So that's going to be 24 minus 10, which means that Mia only has 14 yards of ribbon with which to complete her projects. And what's more, we want to figure out the greatest number of projects that Mia can complete with this ribbon. So we're going to take that 14 yards that she has, and we're going to divide it by how many yards is required per project, and that's 1 2/4. Okay? And by performing this division here, we'll be able to figure out how many projects she can complete. That said, you're probably saying to yourself, well, how am I going to perform this division here? The very first thing I'm going to do is rewrite 14 as 14 over 1. And likewise, I'm going to rewrite this mixed number as an improper fraction. And as you may recall, to do that, you do 1 times 4, which is 4, plus 2, which is 6. So this is 6 over 4. So far in this video, we've seen how to add, subtract, and multiply fractions. We haven't encountered a problem in which we have to divide fractions. Thankfully enough, that's pretty simple. You follow the algorithm keep, change, flip. And that tells you to do this. Keep this first fraction the same. So 14 over 1 stays the same. Change, you're going to change from division to multiplication here. And then flip refers to this second fraction, and it says rewrite it as its inverse. So instead of being 6 over 4, it's going to be 4 over 6. And just like that, we've rewritten this division problem involving fractions to be a multiplication problem, which we know how to do. And you just multiply straight across. That is to say, you do 14 times 4 like this, and then 1 times 6 like that. Of course, 14 times 4 is something I'm going to work off to the side, whereas 1 times 6 is pretty easy. It's just 6. So let's do 14 times 4 right here. 4 times 4 is 16, carry a 1. 1 times 4 is 4 plus 1 is 5. So this is 56 over 6. And again, that really doesn't answer this question because we want to know how many projects she can complete. So we're going to have to convert this to a mixed number. And to do that, we're going to regard 56 over 6 as long division by reading it as 56 divided by 6. And now the question becomes, how many times does 6 go into 5 without going over? It doesn't. How many times does 6 go into 56 without going over? Well, 6 times 10 would be 60, whereas 6 times 9 would be 54. So we're going to go with 9 here. 9 times 6 is 54. 56 minus 54 is 2. And again, since we can't proceed without adding a decimal and 0 placeholders, we're just going to write this as a mixed number. Again, this is our whole number, so this is going to be 9. This remainder is going to be our numerator, and this right here is going to be our denominator. So this is 9 and 2/6. Again, 2 and 6 have a common factor of 2, so we can divide both of them by 2. This becomes 9. 2 divided by 2 is 1. 6 divided by 2 is 3. So in other words, Mia can complete 9 1/3 projects. In other words, she can only complete 9 full projects. Okay. So this one's either 9 1/3 if you want an exact answer. Otherwise, you would say she can only do 9 projects, given that she only has 14 yards with which to work. So that's this one. All right, number 5 says, Paul spent 1/4 of his money on food and another 3/10 of his money on soda. If you start with $5, how much of his money is left? So the point I want to make in this problem is this. Fractions are the same as decimals, and in some cases, it makes more sense to work with the decimal equivalent of a fraction rather than the fraction itself. And as it happens, when you're dealing with money, you typically want to work with decimals. So the very first thing I'm going to do is convert 1/4 to be in decimal form. We should know that that is 0.25. And likewise, we should know that 3/10 is the same as 0.3. Now, I'm going to go ahead and make those conversions for you very quickly. But in future problems, I'm not going to do that once I show you how to convert these two to decimal form. Again, we're trying to convert 1/4 to be in a decimal, so we can treat this as long division, notably as 1 divided by 4, And now we're asking ourselves, how many times does 4 go into 1? It doesn't, so I have to add my decimal here. Again, technically 1 has a decimal. I'm going to add 2 0 placeholders. Again, 1.00 is the same as 1. And once I added that decimal, I'm going to bring it up right here. And the question becomes, how many times does 4 go into 10? It's going to be 2 times without going over, given that 4 times 2 is 8. 10 minus 8 is 2. And now we can drop down this decimal. How many times does 4 go into 20? That's 5 times. 4 times 5 is 20 with no remainder. So just like that, we convert it 1/4 to be a decimal. Let's do the same thing for 3/10. Again, we're going to regard this as division, notably as 3 divided by 10. We start by asking ourselves, how many times does 10 go into 3? It doesn't, so we have to add a decimal and a 0 placeholder. Again, you can add as many 0 placeholders as you need to perform the long division. So now the question is, how many times does 10 go into 30? Well, we have to bring up our decimal first. And once we bring up the decimal, we can disregard it down here. So instead of being 3.0 down here, it's now 30. 10 goes into 30 3 times. 10 times 3 is 30 with no remainder. And just like that, we converted that one to be a decimal as well. So now the question is, how do we perform these operations with decimals? So we know he starts with $5 and he spent 1/4 of his money on food. So we're going to take 5, we're going to multiply it by 0.25, which is the same as 1/4. And we're multiplying a whole number in a decimal now. To proceed, I'm going to shift this decimal 2 times to the right. I'm going to take note of that, and this becomes 25 times 5, albeit with those 2 decimals that I shifted to the right here to shift back into the left. 5 times 5 is 25, so bring down a 5 and carry a 2. 2 times 5 is 10, plus 2 is 12. Bring in our 2 decimals, 1, 2. So we can see that a quarter of $5 is $1.25, which means that we have to subtract that from $5. Let's work this out. Again, we're subtracting decimals now. The very first thing you can do is drop down your decimal in place. We're not going to move it. 0 minus 5 we can't do, so we're going to have to borrow. This is going to become 4. This is going to become 10. This is going to become 9. And this is going to become 10. 10 minus 5 is 5. 9 minus 2 is 7. And 4 minus 1 is 3. So we can see that after spending a quarter of his money, which is the equivalent of $1.25, he has $3.75 left. Now let's go ahead and do the same thing with 3/10. So now that he has $3.75, we got to figure out what 3/10 of 375 is, and we're going to multiply that by the decimal equivalent of 3/10, which is 0.3. And as you can see, we're multiplying 2 decimals now, notably 3.75 and 0.3. In order to proceed, I'm going to shift this decimal in 3.75 2 times to the right, so rewrite that as 375. And likewise, I'm going to shift this decimal in 0.3 1 time to the right to rewrite that as 3. So in total, I move my decimal place 3 times to the right. Once I work this out, I'll shift it 3 times to the left. So 5 times 3 is 15, drop down a 5 and carry a 1. 7 times 3 is 21, add 1, 22, drop down a 2, carry a 2. 3 times 3 is 9, 10, 11. Bring our 3 decimals back in, 1, 2, 3. So we can see that 3/10 of 375 is $1.125. So we're going to take 3.75. We're going to subtract 1.125 from that. And again, we're going to have to add a 0 placeholder here. 0 minus 5 we can't do, so we're going to have to borrow. This becomes 4. This becomes 10. 10 minus 5 is 5. 4 minus 2 is 2. 7 minus 1 is 6. Drop down our decimal in place, and 3 minus 1 is 2. So After spending a quarter of his money and then 3/10 of his money, he has 262.5 left. Okay, and if you wanted to, you can round that to be 2.63. But again, the point of this problem is when you're dealing with uh, fractions and money, you may want to consider converting those fractions to be decimals as well. Okay, so that's that one. All right, number 6 says Sally has a piece of cloth. She used 1/3 of a foot of the cloth to make a pillow cover and another 4/7 of a foot of the cloth to make a tablecloth. If Sally started with 2 feet of cloth, how much cloth does she have remaining? So for this one, we're going to represent it like this. She started with 2 feet. She used 1/3 of a foot to make a pillow cover and 4/7 of a foot to make a tablecloth. So the very first thing we're going to do is rewrite this whole number so it's a fraction as well. And we can do that by placing it over 1. So this becomes 2 over 1 minus 1/3 minus 4/7. And in order to subtract these fractions, they have to have the same denominators. Right now we have denominators that are different, notably 1, 3, and 7. So I'm going to place these denominators over 21. And to do that, I'm going to have to rewrite all these fractions such that they have those denominators. To make 121, I have to multiply it by 21. And I'm also going to have to multiply its numerator by 21 to keep this fraction proportional. And in case you can't do this in your head, we can do it off to the side. 21 times 2 is 1 times 2, which is 2. 2 times 2, which is 4. So this is the equivalent of 42 over 21. To write 3 as 21, we have to multiply it by 7. And likewise, we're going to have to do that to its numerator. 3 times 7 is 21. 1 times 7 is 7. And finally, to write 7 as 21, we have to multiply it by 3. 7 times 3 is 21. We're going to have to do that to its numerator. So this is 4 times 3, which is 12. Now that we've rewritten these fractions such that they all have the same denominator, we're going to just make them into one big fraction like this. And we're going to do 42 minus 7 minus 12. Let's go ahead and combine this 7 and 12 to make the math a little bit easier. This is 42 minus 19 over 21. If you want to do that in your head, that's great. Otherwise, you can work it off to the side so as to avoid making a simple mistake. 2 minus 9 we can't do. We have to borrow. This becomes 3. This becomes 12. 12 minus 9 is 9, 10, 11, 12. That's going to be 3. 3 minus 1 is 2. So this is 23 over 21. Of course, this is an improper fraction insofar as its numerator, 23, is bigger than its denominator, 21. So we're going to try to write this as a mixed number. As you've seen so far, that's not too hard to do. We're just going to treat this fraction as long division by reading it as 23 divided by 21. And the question becomes, how many times does 21 go into 23 without going over? It's 1 time. 21 times 1 is 21. 23 minus 21, well, that's going to be 2. So this becomes 1 and 2 over 21. Okay, so that's the answer to this one. If she started with 2 feet and she used 1/3 of a foot and then 4/7 of a foot to make those two things, she'll be left with 1 and 2 over 21 feet of tablecloth. Okay, so that's that one. Let me try to scroll so we can see this problem. Have enough room to work in. All right, number 7 says a container is 1/3 full of water and 1/4 full of oil. What fraction of the container is empty? So, in other words, we're going to take a container, which is 1. We're going to subtract that 1/3 full of water and that 1/4 full of oil from it. And Again, we're going to have to rewrite this whole number as a fraction by placing it over 1. So this becomes 1 over 1 minus 1/3 minus 1/4. And again, we want to rewrite these fractions such that they all have the same denominator so we can perform this subtraction here. It's pretty easy to do in this case. 1, 3, and 4 have a common factor of 12. So that's what we're going to use in our denominator. Okay, so to make 1/12, we have to multiply it by 12. And likewise, we're going to have to do that to its numerator. 12 times 1 is 12. So this is 12 over 12. To write 3 as 12, we have to multiply it by 4. And likewise, we're going to have to do that to its numerator. 3 times 4 is 12. 1 times 4 is 4. All right, to write 4 as 12, we have to multiply it by 3. And likewise, we have to do that to its numerator. 4 times 3 is 12. 1 times 3 is 3. And now that we have fractions with the same denominators, we can make this one big fraction over the same denominator and do 12 minus 4 minus 3. In other words, this is 12 minus 7 over 12. 12 minus 7 is going to be 5. So this is 5 over 12. And we can't reduce that. So if this container is 1/3 full of water and 1/4 full of oil, it means it's 5/12 empty. Okay, so that's that one. All right, number 8 says Kathy had $10 and gave half of it to her brother. She then gave a third of the remaining amount to a friend. How much money will Kathy have left? All right, so for this one, I'm actually going to use the fractions to work it out. And again, you could do it either way. You can convert these fractions to decimals and go from there, or you can just work this out involving fractions. In this case, the fractions aren't that difficult to work with. We have 1/2 here and 1/3 here. And the reason I don't want to convert this one to decimal is this. 1/3 is the same, as you may remember, as 0.3333333. Repeat it. So again, I'm not going to work with decimals in this case because this decimal doesn't work out that nicely. So let's go ahead and get started. She had $10 and she gave half away to her brother. So we have to figure out what 1/2 of 10 is. Most of you know 1/2 of 10 is 5, but I'm going to work it out for this video. Again, we're going to write 10 as 10 over 1, and now we're going to multiply straight across. 10 times 1 is 10, and 1 times 2 is 2. Again, we're going to treat this as long division or division. 10 divided by 2 is 5. So half of 10 is 5, which means she gave $5 away to her brother. And again, that's 10 minus 5. That leaves us with that leaves Kathy with $5 left to herself. Okay. Then we're told she gave a third of the remaining amount to a friend. So we got to figure out what 1/3 of 5 is. So that's going to be 5 times 1 over 3. And let's go ahead and work this out. Again, we're multiplying a whole number by a fraction. So let's rewrite that whole number as a fraction by placing it over 1. Multiply straight across. That is, do 5 times 1, which is 5. 1 times 3, which is 3. And now this says that 1/3 of $5 is 5 over 3. That's the amount she gave away. So we're going to have to subtract that from 5 now. So this is 5 minus 5 over 3. And in order to subtract these fractions, we have to rewrite them such that they have the same denominators. Again, this has a denominator of 1. And this is pretty easy to do. We can rewrite these with denominators of 3, given that 1 and 3 share a common factor of 3. To write 1 as 3, we multiply by 3. We're going to have to do that to its numerator. So this is 15 over 3 minus 5 over 3, which is 10 over 3. Okay? So she has $10 over $3 left. But that said, we can't leave it as an improper fraction. So we can either convert this to be a decimal to have an answer in decimal form, or we can convert it to a mixed number. Since we're dealing with money here, I'm going to convert this to be a decimal. So let's go ahead and see what that looks like. We have 10 divided by 3. Okay? And so we're start by asking ourselves, how many times does 3 go into 1? It doesn't. How many times does 3 go into 10? That's 3 times without going over. 3 times 3 is 9. 10 minus 9 is 1. At this point, we have to add a decimal here. And I'm going to add 3 zero placeholders, which is going to enable me to bring down one of these zero placeholders here and bring up this decimal here. So now the question is, how many times does 3 go into 10? That's going to be 3 times without going over. Again, 3 times 3 is 9. 10 minus 9 is 1. Bring down one of our zeros here. How many times does 3 go into 10? That's going to be 3 times. 3 times 3 is 9. And as we can see, this is just going to repeat infinitely. So the answer to this one is she'll have $3.33 remaining. If you wanted to express that as a mixed number, we can do so. Again, we would do this with the long division, 10 divided by 3. 3 goes into 10, 3 times without going over. 3 times 3 is 9. 10 minus 9 is 1. Instead of adding these decimals, we can now write this as a mixed number. Again, this is our whole number, so this would be 3. This is our numerator, and this is our denominator. So 3.33, repeat it, are 3 1/3 dollars left. Okay, so that's that one. All right, number 9 says Carl used 10 2/9 of an inch of string to tie a parcel and another 5 1/4 of an inch of string to tie a box. How much string is left if he started with 20 inches? So this looks like this. 20 minus 10 2/9 minus 5 1/4. And as you can see, we're subtracting a whole number, notably 20, by two mixed numbers. So we're going to have to do some conversions here in order to proceed. I'm going to write 20 as a fraction by placing it over 1. Likewise, I'm going to convert these mixed numbers to improper fractions. To do that for this first one, we're going to do 10 times 9, which is 90 plus 2. So this is 92 over 9. And to convert this mixed number to an improper fraction, I'm going to do 5 times 4, which is 20, plus 1, which is 21 over 4. All right, now that we've done that, you can see we're subtracting fractions now. And as you may have picked up on this video, in order to proceed, these fractions have to have the same denominators. So we're going to have to find a common denominator between 1, 9, and 4. And if we think about it, the easiest one's going to be 36, given that 9 times 4 is 36. So we're going to place these all over 36. To write 1 as 36, you would multiply it by 36, which means you're going to have to multiply its numerator by 36. And so as not to make any mistakes, I'm going to do that off to the side here. So this is, and let me rewrite this. Usually when you do multiplication by hand, you put the bigger number on top. So this is 36 times 20. 6 times 0 is 0. 3 times 0 is 0. Before you start multiplication with the second term, you have to add a 0 placeholder. 6 times 2 is 12. Carry our 1. 3 times 2 is 6 plus 1 is 7. This is 720 plus nothing, so this is just 720. So this is 720 over 36. To write 9 as 36, we would multiply it by 4. Again, 9 times 4 is 36, and likewise, we're going to have to do that to its numerator. So this is 92 times 4. 4 times 2 is 8. 9 times 4 is 36. So this is 368 there. And finally, to write 4 as 36, we multiply it by 9, which means we're also going to have to do that to its numerator. And I'm going to do that off to the side so as not to make any mistakes. 9 times 1 is 9. 9 times 2 is 18. Okay, so this is 189 over 36. All right, and as we've seen in this video so far, now that these are all written with the same denominator, we can do this. 720 minus 368 minus 189. And to make this a little bit easier, I'm going to combine these two real quick. Notably, I'm going to do 368 plus 189. 9 plus 8 is 17, carry a 1. 6 plus 8 is 14, plus 1 is 15, carry a 1. 1 plus 3 is 4, plus 1 is 5. Okay, so this becomes 720 minus 557 over 36. Now let me try to scroll down here so we can see what's going on. All right, so let's do this math now, notably 720 minus 557. Can't do 0 minus 7, so I have to borrow. This becomes 1. This becomes 10. 10 minus 7 is 3. 1 minus 5 I can't do, so this becomes 6. This becomes 11. 11 minus 5 is 6, and 6 minus 5 is 1. So this is 163 over 36. And while we are technically done, we can't leave this as our answer. We have to convert this improper fraction to be a mixed number, and we do that by performing long division, notably by doing 163 divided by 36. So we're asking ourselves, how many times does 36 go into 1 without going over? It doesn't. How many times does 36 go into 16 without going over? It doesn't. How many times does 36 go into 163 without going over? I'm going to use some estimation to try to figure this out. I'm going to say this is 40 and this is 160. I know 40 times 4 would be 160 evenly. So I'm going to say this is about 4 times, and let's work that off to the side to confirm that. 6 times 4 is 24. Carry a 2. 6 times or 3 times 4 is 12, 13, 14. Okay, if I were to add 36 to 144, that would be greater than 163. So 4 is going to work in this case. So 36 times 4 is 144. Let's subtract. 3 minus 4 we can't do, so we're going to have to borrow. This is going to become 5, and this is going to become 13. 13 minus 4 is 9, and 5 minus 4 is 1. 1 minus 1 is nothing. So if we were to write this as a mixed number, it's going to be 4 as our whole number and 19 in our numerator over 36. Again, 19 is a prime number, so we can't reduce this anymore. All right, so that's that one. And finally, number 10 says a box of chocolates includes 24 chocolates. If 1/4 contain nuts, how many chocolates do not contain nuts? So if 1/4 contain nuts, that means 3/4 do not contain nuts. Again, 1/4 plus 3/4 is 1. So to figure out how many do not contain nuts, we're going to do 24 times 3/4. And to multiply a whole number by a fraction, you want to rewrite that whole number as a fraction by placing it over 1. And then you just multiply straight across. This becomes 24 times 3 over 1 times 4. 1 times 4 is just 4. 24 times 3, I'll work off to the side here. 4 times 3 is 12, carry a 1. 2 times 3 is 6, plus 1 is 7. So this is 72 over 4. And let's go ahead and see if that long division works out evenly. Again, this is the same as 72 divided by 4. 4 goes into 7 one time without going over. 4 times 1 is 4. 7 minus 4 is 3. Drop down this 2. 4 goes into 32. 18 or 8 times without going over. 8 times 4 is 32. 32 minus 32 is 0. So we can see that 72 divided by 4 is 18. So if there are 24 chocolates in this box and 1/4 contain nuts, that means 3/4 don't contain nuts, which means 18 don't contain nuts. Okay, so that's that one. And that is it for this video. I hope you found it very helpful. Admittedly, even though these were simple problems, there were a lot of challenging aspects in them. For example, we had to convert whole numbers to fractions, mixed numbers to fractions, and all along the way we had to do a lot of long division and mental math. So this video in and of itself is a good preparation for the ASVAB. I hope you found it helpful. As always, you're more than welcome to leave feedback in the comment section below. If you like the content I'm creating, by all means, consider subscribing to my channel. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.